Hi, this is Miss MacPhee, and this is our first video for the 2018-2019 school year for my Math 6. Welcome. Thank you for watching. So our curriculum this year is through Open Up Resources, and I gave parents at the beginning of the year some information. They do have some family support if you're ever curious about helping your child at home. We were looking at this problem at the end of class today. We're doing a really good job with investigating triangles, and today we looked at, can we identify a base and a height for any given triangle, knowing that sometimes we might have to rotate the triangle to find the base, and maybe the height is going to be outside of the triangle, and that's okay as long as we have that perpendicular 90-degree distance straight up and down between our base and our height. And students are doing a really good job identifying that. They're also doing a fantastic job recognizing that a triangle is in fact half of a parallelogram, which is why we've come up with that beautiful formula, base times height divided by 2, to find our area. So we've been doing counting and decomposing shapes and using the formula to find area. And then we have this shape. So I'm going to show you two different ways to find the area. The one way that I gave a little hint as you were leaving is if you want, use your tracing paper and your straight edge. I just used an index card as mine. And then if we want, we could rotate the figure. So now we can find our base, which is 1, 2, 3, 4, 5, 6, 7, 8. And our height, straight through the center, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we could do base times height divided by 2, which is 8 times 13 divided by 2, which comes to 104 divided by 2, which gives us an area of 51 units squared. So that might work for some students. A lot of students today were starting off with another strategy that makes so much sense that I wanted to use it and then talk about how we could keep going with it. So a lot of students were recognizing, well, hey, why don't I start by finding this big area of the square? And the square going across does turn out to be 12 for our base, as well as 12 for our height. So this whole area of our square is 12 times 12, which is 144. And then some students were just dividing by 2. So in fact, what we can do here is let's subtract what we don't need. We don't need this green triangle. So that's a base of 1, 2, 3, 4, 5, 6, and a height of 1, 2, 3, 4, 5. So this triangle has an area of 6 times 5, which is 30. Divided by 2. So I'm going to go ahead and subtract 15. And I'm going to get an answer of 129 that's left. And then, hey, I can subtract this triangle. My height I already know to be 12. And my base is 1, 2, 3, 4, 5, 6. So this triangle that I can also subtract is base times height divided by 2, which is 72 divided by 2, which is 36. So now I can also subtract 36, and I get 93. And then maybe you're recognizing, oh wait, Miss MacPhee, here's another triangle that I don't need. And you're right. Here's my base, which we know to be 12. And here's our height, 1, 2, 3, 4, 5, 6, 7. So that would, for that triangle, would be 12 times 7 divided by 2, which is 84 divided by 2, which is 42. So now I can subtract this triangle. So now I've subtracted all of this green area out of that big square to be left with just my black triangle there in the center. And I also get an answer of 51 units squared. So two different ways, either tracing and then recentering it to count our base and our height, or again, looking at the big picture and taking out what we don't need. You're working really hard every day. You've started my year off so well this year. Thank you, and I will see you tomorrow. Bye.